So, buenas tardes. I'm afraid that's pretty much all I can put on the table in terms of Spanish, so please allow me to continue in English. I'm Christopher Heppling. I'm with the Fraunhofer Institute for Solar Energy Systems. I'm in renewables for 30 years now. Thank you very much to Vicky and Andrea for inviting me, for having me here. It's really my pleasure to be here, and we had a wonderful workshop. Alberto, thanks for coming again. So there are three topics I would like to discuss with you in my talk. It's energy, the role of hydrogen in the overall energy system, and of course Barranquilla. So what can you as a city and as a state can contribute in this overall game, so to speak. So let's start with energy. It's a little distorted, but it's fine. This is the energy we have been using over the last 150 years. We started with coal in the late 1900s, followed by oil and gas. So now we use about 160,000 terawatt hours of energy every year. For those of you who are not in the energy sector, just believe me, it's a lot. So we consume every year for transport, for heating and cooling, and for power generation. And when we started using the fossil energy, it was based on the assumption that the emissions, CO2, would not have any impact to the atmosphere and to the living on the planet. At that time, it was fair to assume, because the sky is blue, still it's blue, but now we know better that and if you would click now, these are the circles of 1 year is one circle. That's the temperature of the globe. And as you can see, the green circle is how we started 150 years ago. And like in the 80s, so the resilience of our global system was exhausted, so to speak. And what you see from the 80s, there was an increase in temperature. So we had 1 century, it was fine, but now from the 80s, the temperature increase is starting significantly. Here you see the same graph again. So roughly, that was the point when things went up. And if we look timely resolved, not only the integral over 1 year, you see there are some months, like the last year, 23, the July was an extremely hot month in over the globe, and that caused a lot of effects. So with the usage of our fossil energy, you can see here, this is the ppm scale, so the amount of carbon dioxide in the atmosphere on the left. And this is the time scale. So that's the South Pole, that's the equator, and that's Mauna Kea, so where usually all those measurements are being taken. But what you can see here very nicely, most of the emissions come from the northern hemisphere. So we also have an issue with north and south, very much so. And but if you look at that, that's where we are right now. And this is the history of our planet in terms of carbon content in the atmosphere. You see these are 300,000 years back, so 800,000 years back. So all the hundreds of thousands of years back, the maximum was 280 ppm, parts per million. Now we're at 420. So that means, and this has two aspects. Never ever has the Earth seen such a high amount of carbon in the atmosphere. It's 50% higher than even 150 years ago, but also the speed. I mean, this is basically in a second, so to speak. So we pump up the atmosphere with carbon, with CO2, and of course we know all of the effects. And there are two things which we have to distinguish. First of all, the weather extremes. We see constantly right now in Brazil, the wildfires, but these are the major and the most extreme weather appearances last year. For example, for the first time we had seen a hurricane with more than 200 miles per hour in wind speed. That has never been recorded before. In Europe we had lots of floods, like in northern Italy, so the whole area was completely on flood. Also was significant was last year in Canada, the wildfires. If you remember, so it went on so all over Canada, and so these are the CO2 emissions in Canada just due to the wildfires in Canada, which was in a total about 500 million tons of CO2 just from this one weather extreme. Weather extremes come and go, you would say, okay, so they're getting more and more. But the tipping points is what we have to really take care of, because tipping points is nothing we can go back. If this tipping point has happened, then that was it. And the major tipping point right now is the melting of both Arctic and Antarctic. And what you see here, for example, that was the ice coverage of the North Pole last year. That was covered, and the median extent over the 30 years before was this one. That was the medium at summer, at the lowest point. So that was last year, and it takes probably 30, 40 years when there is no ice in winter. So that's a tipping point, and of course it leads to, so we have to be aware of where we are and the speed, and that calls for action, for really fast action. So the global community has understood the urgency of reducing further carbon emissions. So there are many global initiatives which try to tackle the reduction of carbon. The first one was the IEA. It was founded in the 70s, and there are many others. Recently, and that's, I would call it a slight breakthrough last year, the 28th conference of the parties, the COP conference in Dubai, for the first time gave an indication that yes, we are in the kind of phase of the beginning of the end of using fossil fuel area. So that's, I hope this is a true tipping point, but all I want to say is we have to act quickly and really as a global community. So the future energy system will be based on electricity, which again will be produced by renewables, period. I mean, this is the baseline. We cannot go beyond this, but it's the cheapest form of electricity anyway. So therefore, sun and wind and hydropower, which you have a lot in Colombia, this will be the backbone of the future energy system, and we should try to use the electrons wherever we can and at the time where they are being generated. We need to reshape our energy system towards flexibility in order to bring the production of electrons and the demand somehow together, demand-side management. But and this is why I'm here, is we have to do the transformation from electrons to molecules, power to X. And that's exactly why I brought this, the fossil energy chart, the 160,000 terawatt hours of energy, because out of that only 13% is renewable, The other 86% is molecular. So, and we have to somehow replace this molecular energy, and this is the power to X topic. And the fourth is whatever we do, because we have seen the high numbers, whatever we do, we have to think of the limitation of resources on the planet in general. So the resource, we have to close the materials cycle. We cannot just always dig out of the ground and dump it somewhere. So recycling has to be mandatory for whatever we think in our further development. So power to X is, and that's, I know it's a busy chart, and it's maybe late for some of you, but it's very easy to read. But so this is once again the backbone: wind, solar, and hydro. Make use of it wherever you can and in the amount you can use it. If there is a like decoupling in time or space, then use your electrons to split water and do water electrolysis to generate hydrogen. The hydrogen can be used in many sectors, like in transport, in heating, in industry, in chemistry. Hydrogen is a very valuable chemistry. If hydrogen, since it cannot be transported long distances so easily, do the hydrogenation, as they call it. The hydrogenation means take a carbon source, carbon dioxide from plants, ideally, from biomass, and do CO2 plus hydrogen and do methanol. That's the simplest hydrocarbon molecule. If methanol, it's an alcohol, it's a liquid, you can use it in many sectors. It's one of the most important basic molecules for chemistry. But from methanol, you can do a further transformation into longer chain molecules like DME, OME, jet fuels. I mean, that's the same type of thing: hydrogen, oxygen, and carbon, just in another configuration. But like kerosene is, of course, a very valuable hydrocarbon, which again can be produced out of methanol quite easily. If you don't have a CO2 source, use nitrogen from the air to hydrogenate, and hydrogen and nitrogen is ammonia. And the world market for ammonia is 180 million tons. And fertilizer are made out of ammonia, for example. Again, very important for this country. And so ammonia is very important as an energy carrier, as a fuel for ships in the long term, but also as a chemistry. So that's power to X, just to give you an indication. I'm really happy to say that the global community understood the urgency, and there are many, many national roadmaps and strategy papers, research papers, whatever. So if you count rightly, and this is yours here, and but the global community is on the hydrogen track, so to speak. And if you look on the timeline, Colombia wrote the hydrogen roadmap 3 years ago. And many others followed afterwards, somewhere beforehand. But I read through the hydrogen roadmap on the flight to here. So a lot of really good stuff is described, also for the transformation of the Colombian energy sector towards sustainability. I recommend a read. So that's one of the graphs which I took out of it. First of all, these are the 5 key pillars of the Colombian hydrogen transition: emission reduction, economic growth, fair transition, national goals, and local communities. All that can be addressed with this new field of hydrogen economy in Colombia. And what's also interesting to see, Colombia has considered hydrogen and its derivatives, like, as I said, the hydrocarbons and the ammonia out of hydrogen, as an export vector. And that's something we discussed in our workshop yesterday. it's competing in a way. You can make money by selling it, but you also need your green products for your own energy system transformation in order to fuel your buses, for example, and trucks and ships from the maritime sector. So this is kind of something which you have to somehow solve like as a country, what can be exported. And of course, with Barranquilla and Cartagena as ports, it's very attractive to export it, especially since we as Germany like to import all these products. So that's why we have a German-Colombian energy partnership. And in the framework of this, we just did a study so we dug deep into the Colombian setting, so to speak. So I've learned a lot about Colombia from the paperwork. And this is what I would like to talk about next. We had in March this year, we had a wonderful workshop there, so the kick-off of the National Hydrogen, I think, workforce or something. So you probably know all of those, or the first 4 people with the former minister Germán Umaña. So the president of Ecopetrol was there. And on the right-hand side, that's our BDI, so like Andy. He's the director for energy. So we had this wonderful workshop. From our side, the parliamentary state secretary was attending, so the Yadir Salazar, the the ambassador in Germany, she's doing, by the way, a wonderful job. So if you want to have anything to do, business or whatever, with Germany, get in touch with her. I mean, I don't know if she sleeps at all, but she's really energetic and like all Colombians I've met, I must say. She loves to work and brings things into reality. And that's our ambassador, the German ambassador in Bogota. So that's what we did. So the project we had was doing a techno-economic assessment of production pathways in Colombia for green hydrogen, ammonia, and methanol, given what's available in Colombia, the potential for renewables, the local infrastructure conditions, and the needs for the local stakeholders. So we put all that on top of each other. So the results were identifying the promising locations, the mapping of the relevant infrastructure, the promising for implementation of large-scale power-to-X plants. I mean, these are big installations if you think of like gigawatts, and the cost, of course. So how did we do that? Now it gets a little technical, so I will go quickly through it. But first, we do a geographic information system data analysis based on satellite data, the local parameters, the harbors and all that, the infrastructure, then the generation of local specific wind and solar parameters, hourly resolved. So we take the generation profiles of all the country based on satellite data, hourly resolved as an integral over the last 10 years in order to have no maximum. Third, then we put that in our solvers, and then that's really technical, so don't worry. And then as a result analysis, we get these bars which indicate the levelized cost of power-to-X product. How much would it be to produce including the whole value chain? And I will, of course, show you some results. So first of all, the GIS data, the geographic information data, restricted areas, and you can believe me, most of the country is restricted because it's forested, you have the Amazon, you have cities, villages, and whatever. Second, the suitability criteria, which takes into account where are the best sites, where you have high wind speeds, for example, or high solar irradiation. Then the overlay, so we put everything on top of each other. Then the site clustering to combine it with the uptakers, with stakeholders. And then we do the site selection, which would be a good site to start or to have this power to X relevant products. So here, for example, you see what we considered as restricted area, and as you can see, it's a lot. You know, the settlements and infrastructure, that's the most, because wherever it's flat and easy and nice, it's developed. You know, so you cannot put wind on top or solar or something. So that's one thing. But ecology and culture, that also is taking away a lot of possibilities for good reasons. Nature reserves, national parks, national monuments, protected landscape, seascape, drinking water protection, all that, of course, has to be included. And, which is very important here in this country, of course, indigenous cultures and cultural heritage, especially if we look into La Guajira. There's a lot of restrictions due to that. And then the land use, you know, like forested and the dense vegetation, hilly landscapes, more than like 5-degree slope, you cannot put solar on top, and so on. So we did that, and this is what's the outcome. So whatever is orange, yellow, and green is a very good suited area for photovoltaics on the left and wind on the right-hand side. And just to give you a hint, if we exclude the cultural restrictions, and I go back and forth, and you see exactly what I mean, La Guajira would be your power hub for the whole country. So if you could manage somehow, and I don't want to touch into that because I'm not grown up in this country, but if you see the potential of La Guajira, this could not only be your green powerhouse for the future, it could be also the prerequisite for your export, because the amount of both PV potential and wind potential is extremely high. So just go back and forth. So whatever becomes green is if you take out the cultural restrictions. Then infrastructure, we looked into the power lines, whatever is out, the pipelines, of course, the industry infrastructure, transport infrastructure, because you have to transport not only electrons by high voltage power lines, you also have to transport CO2 if you want to have hydrocarbons, because you have to bring hydrogen with CO2 together. And if the CO2 comes from a biomass plant, for example, like in Cali and Valle de Cauca, so there's a lot of sugarcane biomass, and that would be a perfect combination, but it's not at the same spot. And wherever the biomass grows is not exactly the best photovoltaic plant because it rains a lot. So therefore, infrastructure is very important, both for electrons, the high voltage power lines, but also the pipelines for natural gas, or in the future also for hydrogen. And water, hydrogen is made out of water. So therefore, that's one thing. Of course, La Guajira is not really blessed with water. So, but other than that, you see here on the right-hand side the map of water, groundwater and wastewater, extremely well suited for hydrogen generation. So here's the, if you look into Barranquilla and Cartagena, first of all, this is a region, I mean, you know that better than me, but let me just tell you, this is a photovoltaic region here, because onshore wind has not a big potential, because it's just not enough wind, but photovoltaic, whatever is yellow here, is very well suited with all criteria I mentioned for photovoltaics, but the offshore wind potential is excellent. So try to keep in mind the combination of offshore wind with, of course, onshore photovoltaics that gives the highest so-called capacity factor, the best opportunity to have low-cost power-to-X products. Also, it's very important, and why you are blessed here in Barranquilla, because the power-to-X production is very well connected to the uptaker, because you have a lot of industry, chemistry, which can use the power-to-X products. For example, Ecopetrol needs a lot of hydrogen. So why not bringing that together? So the offtake in Cartagena and Barranquilla is excellent. Also, you have an excellent transmission line connection that's all available. And yes, you have high power prices, I've heard that, but if you ramp up your photovoltaic capabilities, the prices will go down more or less automatically. But here, and the water sources with surface water and treated wastewater is also excellent here. That's something which really sticks out. The local offtake, like Yara with green ammonia, is something, Ecopetrol. There's a very good synergy potential for local use. Of course, for export as well, because these are the two big harbors, but also for local use. And if I just may touch the La Guajira topic again, if it would be possible, and I know this is a big if, to connect La Guajira with a pipeline, with a hydrogen pipeline, there are outstanding large-scale wind and photovoltaic clusters available in La Guajira. And it's not too far, the whole northern shore from La Guajira to Cartagena and Barranquilla. This would be the powerhouse of Colombia and way beyond, because whatever you don't need for your own purposes is ready to export. And once again, we as Germans, we are happy to buy whatever you produce. So, well, I maybe skip that a little bit because that's the outcome of all this modeling is, first of all, the cost of the hydrogen when it comes out of the electrolyzer. We always think of a gigawatt. So don't start and think too small. Gigawatt is the right size for whatever you do. So that's one cost. Second, the domestic power-to-X product costs with additional molecules, either carbon or ammonia. And third, if you would ship it to Europe, of course, I would think of Europe, Rotterdam or Hamburg. So these are the three cost sectors which come out of all this modeling, and we do that for 10 years now, in a way. And I would like to indicate, I mean, these are the numbers. Yes, gigawatt means giga dollar investment. This is somehow correlated, you know, just to, but these are the installations you need for a power-to-X plant. I just show you the pictures here, and of course, don't discuss the numbers. But the numbers you have to keep in mind, and we have discussed it yesterday, so the electricity generation, both wind and solar, accounts for like 50% of your final product. The levelized cost of power-to-X is dominated 50% from the fact how cheap you can produce your electrons. So therefore, look out for good sites which can combine both solar and wind at the same time. What is neglectable, for example, is ship transport, 3%. Also neglectable is taking the nitrogen out of the air with the air separation unit. That's only 1% of the overall cost. Storage is neglectable. And the synthesis, like the chemistry behind this, is neglectable. So all that is dominated by the renewables and by electrolyzers. The rest is small numbers, so to speak. So I will skip that also a little bit. These are the numbers. This is the outcome, but we don't talk technical details now. But this is at which cost you can produce more or less now. 2030 is if you would start developing your plants now. On the order of 300 euro per megawatt hour would be the cost. And in La Guajira, it would be like 20% cheaper because they have a much higher capacity factor due to the higher wind speeds. Onshore wind and, of course, offshore on top would help as well. What's also interesting to see that liquid hydrogen it's not outrageous high because liquid hydrogen can be transported again and can be also used in your truck sector for road transport. The numbers we can discuss later, so therefore I know it's late for you and not everyone is here anymore, but just to indicate with this slide that hydrogen economy is not just producing a molecule, it's a whole new economy. That's what makes it so attractive. It starts from politics making, and we have heard that before several times. The regulatory framework is extremely important to accelerate this new field. Policy and regulation, then finance and investment. That's why most of you are here, because only money drives all these developments. Then the industry development and activation. You have a lot of industry here already, especially the uptakers, but the German companies, the ThyssenKrupps, the Siemens, and all those, they are happy to make also investments and installation here, also for production. Then we need sustainable commercial economic models, because only that drives the financial investment decisions. Skills education and research innovation, we've discussed that also in the last round, is very key, but I can tell you Colombia has a very high level of education from school to academia, and so therefore you're blessed with highly trained students, and academia is really belongs to the best in the world, so just take them and bring them in the right sectors. Then setting up infrastructure is the next thing. As I said, pipelines, the high voltage lines. Then we have to quantify the climate drivers and the social drivers, resource asset, and then, of course, the global collaboration, because you cannot do this as an individual country. No country can do that. Be connected to the rest of the world. I mean, you are, so, but that's a prerequisite. Yeah. So the conclusions, first of all, the claim as a future hydrogen power-to-X power plant of Colombia, which is described in your strategy, is absolutely justified. You do have the potential from all aspects. Go for it. That's all I can tell you. Just do it. I mean, just do it. And especially Barranquilla is a great hub, so to speak, for a hydrogen hub or a hydrogen valley, however you would call it, because you have everything available. You have the renewables, you have the industry, you have the skilled people, the climate is good. I heard so much good things about living in Barranquilla, so you don't have to bring in people, so they live here happily anyway. Try to keep in mind, if La Guajira can contribute to the overall picture, it will go much faster and cheaper, because it's just, I flew with this delegation in a helicopter over La Guajira. I mean, it's just a blessed country for land for power-to-X products. You know, it could be so easy, but I know it's not. But it just tell you, try to stay on this topic. Finally, that's really my last slide. Just to come back to my first remarks on the first couple of slides, you know, the window to act is finite and it's shrinking. So I don't want to scare you now. So I mean, you want to have a happy life and a nice evening, but we have to be aware that the longer we wait, the harsher the measures would be to reduce the carbon emissions. And what we see now every year with all the weather extremes and with the melting poles, These are not just early signals anymore, so we are right into it. And so therefore, keep in mind the window of acting is shrinking, and so we have to be fast. And there will be a dual structure between electrons and molecules, always be. So we try to bring in more green electrons into our energy system, but at the same time, we have to transform them into green hydrogen and derivatives. So that's a peaceful coincidence. It's not a competition, so we need both at the same time. And one aspect which I learned a lot is here. And I want to read this: the best innovations and processes. And I'm in research for 30 years, and we're so happy at Fraunhofer. We did so much, like MP3 was a Fraunhofer development and so on. But all that technologies are meaningless if we don't understand how it affects the life of people. And so if we cannot bring technology to people's life, that they would decide for new technologies with less carbon emissions next to it. And that has to do with communication. And we have to put people into the center of our thinking and of our acting, because technology on its own is really meaningless if there is no uptake by all of us, for example. And this again reflects back the level of education is very important. And the last point is really, let's work together. So this is an international effort. It's a challenge for all of us. And I'm really traveling a lot in the world. And I mean, the mindset is there. So people have understood about the urgency and collaboration. But still, we act still too much competitively. So let's try to be more together and not competitive, but more in a collective way. So with this, thank you again for having me here. It's my sincere pleasure, and the pleasure will continue tomorrow, I'm sure. Thank you again.